So today I'm going to show you how to turn a normal RGB image, when you shoot narrowband, into HOO. HOO, it means hydrogen, oxygen 3, oxygen 3. So the image will have more oxygen 3 in it, which is the green and blue channels. And now I'm shooting with an OSC camera, so really this is false HOO, true HOO. To have a true HOO, you need a mono camera with different filters. But I'm gonna show you how to do it with a OSC camera. First I start by cropping. Obviously this is a stacked image. I start by cropping the image and do background extraction with Graxpert. You can also input it into Graxpert, but this is easier. And leave the default setting and press apply. And as you can see, it is the narrowband, like normal RGB channels. You have the channels here. As you can see, these are a lot dimmer. So what I'm going to do is I'm gonna fix the stars a bit first, because they're a bit elongated. Denoise the image, then I'm going to separate the channels. And I won't bore you with this side, just will fast forward it. Okay, the stars are now fixed. Now I'm going to do denoising, and since there is a lot of noise here, I'm going to choose a pretty aggressive denoising, 0.9. Because this image was taken with a ZW ASI 178MC, which is a planetary camera, so it's not a cold camera. It will be more noisy than a cold camera. Alright, so the image is denoised. Now I'm going to leave the stars there for now. Do a color calibration. I hope it works like that. Okay. I need to find the catalog for the Monkey Head Nebula, because I'm going to search it real quick because I forgot. Okay, it's NGC 2174. Okay, color calibration SPCC. This I will turn it to star type G2V in brackets, which is a sun like our sun, the same colors as I'm told. Okay, it's important to do color calibration before separating the channels. Okay, as you can see, the image turned colors, so it was great to do this. Now go to image processing, channel extraction, split channels. Now we're gonna split the channels. I'm going to do RGB to keep it simple. Let's apply, and this will go to the directory which you have set up here. In my case, it's the Siril folder. I created a Siril folder in my documents. Now as you can see, BGR. Now drag the mouse over the BNG and put it in the lights folder, and we're gonna stack these to create more signal in the O3 channel. And go to OSC processing without DBF, so stack them. It's important to not remove the stars first, because to stack these you need the stars, and the software needs the stars to align. So StarNet, we do it after, not now. This is the result. As you can see, this is the O3 channel. Now we're gonna go to image processing, channel extraction, split channels, remove these two. Now I know it's the O3 channel, but all the channels are the same, as you can see. So only choose the R channel, because if you choose the green and the blue, Siril crashes for some reason. I don't know if they fixed it, but before it was like that. I'm gonna do O3, so I recognize it. Now go to image processing, composition, RGB composition. Now, this is the luminance channel, and these are the RGB channels. In the luminance channel, always put the R channel. It's got the most signal. In the red channel, put the R channel. In the green channel, put the O3. And in the blue channel, put the O3 as well. And close. Now we're gonna do a background extraction. Leave the settings as usual. Okay, as you can see, it's boosted the signal. So now, as you can see, the background is a bit bluish. If you want, you can go to pixel matte. I'm gonna show you how to do it, and you can adjust the. I go to input both the channels here, and you can adjust how powerful is every channel. In this case, I'm gonna boost the R a bit more, times 1.3, and see the result, if I like it or not. You can also boost the other channels. Yeah, as you can see, the blue went away, the blue noise in the background. I like this more. Okay, so now I'm gonna do star processing, star net removal, and remove the stars. And we're gonna process the data. Okay, now I can start stretching with the GHS. I drag a box over a part of the nebula, part of the outer nebula, not the inner one. Because if you choose a very bright part of the nebula, it will stretch it a bit awkwardly. I stretch a bit before starting. Then I choose the eyedropper tool, which will stretch only this part, or values like it. Decrease the highlight protection so we don't blow out the background. Increase the contrast. Eyedropper tool. Increase the highlights. The contrast. It's basically like this, going back and forth. I have a special video dedicated to stretching in Siril. I will link it in the description. And to be honest, I think I'm gonna leave it like that, because if I go a bit more, it will overstretch it. I'm gonna do a slight curve to increase the highlights, and a S-curve to increase the highlights and darken the background. And that's it. I'm not gonna touch it anymore. So I'm gonna save this starless monkey. You can name it whatever you want. Okay, save as 16-bit, and now we're gonna go to Photoshop. And in Photoshop we are gonna do some masking to bring out the O3, which the O3 should be in the center of the nebula. So what we do is right click, duplicate layer, and then choose this one, add layer mask. Go to select color range and choose the central part. Now we need to increase the fuzziness, so because you can see there is only a small area selected at the moment, but if you increase the fuzziness it will go up. We don't need the whole nebula, we only just need this part selected, just a bit more maybe. Okay, now press Alt and left click and filter, blur, Gaussian blur, and do some blurring. I normally use 8. Go back to the main, click on this one, and image adjustments and curves, and we're gonna increase the blue and green, which will bring out the O3. I'm gonna do some saturation as well. More saturation. You can basically play around however you want, but since we are doing HOO, I like to bring the blues a bit, so they are a bit pronounced. And normal color of O3 is teal. So basically try to get it that way. It's looking pretty good in my opinion. Maybe a bit more blue. Maybe. It's a matter of kind of balancing. Yeah, it looks pretty good. So now I'm gonna apply mask and merge visible, and I'm gonna denoise the image a bit because there's a lot of noise. I'm gonna duplicate the layer again, add layer mask, and choose only the background. I'm gonna do the second option, choose all around the background. So now I'm gonna denoise the background, Alt and left click, filter, blur, Gaussian blur. And I'm gonna denoise the background because the background's a bit noisy. And I'm gonna darken it a bit as well. It's important to not go crazy, because if you go crazy it will look fake, the image. Okay, that looks pretty good to me. Apply layer mask and merge visible. And you can also, I'm gonna do some sharpening as well. Okay, blur. I'm gonna choose a bit less. Filter, sharpen, and then sharp mask. And just sharpen it a bit. You see it sharpened a little bit. But if you sharpen too much, you can also do smart sharpening. If you sharpen too much, it will increase the noise. Yeah, did sharpen it, but sharpened it too much in my opinion. I like to sharpen an image, but when you sharpen too much it will look fake. Maybe go with that, okay. apply layer masks, and that's it. I'm not gonna play with it anymore. I'm just gonna fix these edges with the healing brush. I'm gonna fix some of these edges because I have a bit of weird noise at the edges. The healing brush is a very useful tool, especially if you have like remnants of stars, which I believe this one is. I'm gonna touch it. That's it. It's gone. And even you can do inside the nebula as well, like that. Save. I'm gonna go into Siril. Open the file that I had. And for some reason it looks more black. So go to stretches and histogram, it will come to the natural color again. When you first open an image in Siril, it will look more black for some reason. I'm gonna increase the black point a bit. Now I'm gonna overwrite my starless.fits. Now I have to save it as a fits file, not TIFF file, and this is a 32-bit. So now we're gonna recombine the stars in image processing, star processing, and star recomposition. Okay. Now do the starless image and the star mask. And I'm gonna increase the stars in the image. And you can increase how much you want, however, how much stars you want. I like a bit of starry image. I don't like just a couple of stars. I like a lot of stars in my image. And basically that's it. This is a false HOO image in Siril. You can play around with the saturation like however to your liking. As you can see, you can increase the blue saturation, but it's to your taste. Everyone has different tastes. If you feel like this is not to your taste and you want to go a bit more, yeah, no problem, go. That is the beauty of this hobby. Nobody is your boss. You do whatever you want. But this is the small guide of the how to do an HOO false image with Siril. If you like this video, give me a thumbs up and follow me for more processing tutorials and imaging sessions, and I will see you in the next video. Clear skies.